Good morning and welcome back. I'm going to do a short video on calculating percent yield, not percent composition like I did just a second ago, but this one's going to be percent yield. So think of it this way. If you had a recipe for making cookies and you read on the back that it's going to make 36 cookies, that's what it should make. And you follow the directions exactly, you put in the exact number of scoops of everything and you cook it the way you're supposed to, and turns out you only got 32 cookies out of your 36. What was the percent yield? Did you get your expected value? So this is really useful in the chemistry world and in types of industry. If you're making something, you want to make sure that you're maximizing your efficiency so that you're getting out of your process what you want. If you're only 50% efficient or 30% efficient, you're probably losing a lot of money. So are you wasting ingredients? Are you not getting done what you need to get done? So percent yield is a very, very simple thing to do. I'm going to run you through how to do another stoichiometry problem first so that we can get some numbers, and then we'll go. So the reaction I have up here is an acid-base titration. So it's a neutralization. We have hydrochloric acid over here, HCl, and we have sodium hydroxide. That's going to be our base. So if I take this and put them together, this is a double displacement reaction. We're going to get water and salt. So if in a perfect world, if I started with 50 grams of hydrogen chloride or hydrochloric acid, how much sodium chloride should I make? Okay, so this is going to be a grams to grams conversion. So again, this is going to be the 3-bracket problem that we've been doing from last week. So I'm going to start with what I know, which is 50 grams. So I'm going to move this down a little bit so I have some room. Oops. Okay, so that's what you were given, 50 grams of acid, and we want to know how much salt we're going to make. All right, so this is going to be grams to grams conversion again. So this is going to take 3 brackets. All right, so in a grams to grams conversion, remember we are going to be dividing by the molar mass. We're going to be doing the mole ratio, and then we're going to be multiplying by the molar mass. So remember what the molar mass is defined as is the mass of 1 mole. So if it's the mass of 1 mole, then there are a couple things in here that we call automatics that you can just write in right now. They're always going to be the same when you're doing a grams to grams conversion. And it's going to be in the first and the third brackets. So in the first bracket, the top numerator is always going to be 1 mole. And the third bracket, the denominator, is always going to be 1 mole. Here, I need to know what the molar mass of HCl is. I have 1 of each one of them, right? 1 hydrogen, 1 chlorine. The mass of hydrogen is 1. The mass of chlorine is 35.5. So that means that the molar mass of hydrogen chloride or hydrochloric acid is 36.5. So that's the number that goes into my denominator. 36.5 grams in 1 mole. Mole ratio, I now need to compare the number of moles I use of the acid versus the salt. They're both 1. So very simply, the mole ratio is going to be, remember, it's the unknown, which is the salt, over the known or the given, which was hydrochloric acid. 1 mole of HCl. So 1 over 1 is my ratio. And now I need to multiply by the molar mass of NaCl. We know the chlorine is 35.5 because we did it over there. And sodium, 22.99 tells me that we're going to round that to 23. Add these two together. It's going to be 58.5. That number goes here. Now I grab my calculator. So we haven't done percent yield yet. First, we have to figure out what we should expect in the world. So starting with 50 grams over here, we're going to divide by 36.5. Okay, 1.36986, blah, blah, blah. Leave that in the calculator. We're now do the mole ratio. It's 1/1. So if I want to multiply by 1 and divide by 1, you're wasting your time, but go ahead. So then the next step, I could skip over the mole ratio just because it's 1/1. But now I have to go to the next bracket, which is 58.5. So I multiply that because it's in the numerator. If it was in the denominator, we divide by it, but it's in the numerator, so we multiply by it. So I'm going to take my answer of 1.36 that I had times 58.5, enter, I get 80.1. So if the world was perfect and everything was good, then if I run this reaction, I use every single last atom of the hydrochloric acid, I should expect to see 80.1 grams of sodium chloride. Like I said at the beginning, if you're in the world is perfect, I should get 36 cookies because that's what the recipe says I should get, but I only got 32. So what this is known as is your theoretical yield. In theory, this is what should happen. If everything's perfect, in theory, you should get 80.1. Well, what if you did this reaction in the lab? You go to the lab, we do it, you measure everything out, you get salt, and let's say you got 75 grams. You didn't get 80, you got 75. So in order to figure out our percent yield, we're gonna need this theoretical number, okay? So give me 1 second, and I'm gonna set up the next part of the problem. So we pause this, and I'll be right back. And I'm back. Okay. So how you calculate percent yield is this. You're going to take the actual mass that you got in the lab, that you physically collected, and you're going to divide it by the theoretical mass of what you should have seen had the world been perfect, okay? So we said before that you calculated the theoretical mass was 80.1. So that's the number that's going to be our denominator. The actual mass should be given to you on problem, or you would collect it in the lab. I think I said 75 grams, so let's set that up. Percent yield. The actual mass is what we got in the lab that we said 75, and we got 32 cookies out of 36, right? So our actual mass we said was 75 grams. Theoretical mass is what we calculated it to be. That was 80.1. I want to multiply it by 100 just so we can get it into being a percent. And now I just take these two numbers and divide. So the math isn't really that scary. I mean, you're dividing two numbers. 75 divided by 80.1 times 100 is 93.6. So think of it this way, we were 93.6% efficient in this reaction. We got 93%, almost 94% of what we should see, we got. Is it possible that this number could be over 100? Yes. In a scenario where maybe you didn't do your measurements right, or you got some contaminants in your reaction, there's something else in there. So it is possible that your actual is going to be higher than your theoretical. Usually that's not the case, but it is certainly possible, okay? So percent yield, actual divided by the theoretical times 100. Actual is the number you actually have in the real world. Theoretical is the number you get from a grams to grams conversion, which in theory should be what you saw. So actual over theoretical times 100, that is percent yield. Okay, sound good? We'll give you some practice problems to work on that in the upcoming week. So enjoy, hope everybody is doing well.